Machine tools should be solid. They should be fast, precise, and durable. This is crucial because such devices are often used for 10 to 20 years, sometimes even longer. They must be designed to perform well over such a long operational period. This is not an area where you can cut corners. Often, a company's existence depends on the reliability of its equipment, machines, tools, or the entire infrastructure. Quite frequently, the first device in a company that starts the production process is a laser cutter. If this machine stops, the whole company comes to a halt. That's why it's so important to have a machine you can rely on. My name is Kimla, and I'll tell you how we created the fastest laser cutters in the world. Big companies, in an effort to humanize themselves, often create certain myths. They claim to have started in a garage to make a massive corporation seem more relatable, even though it actually belongs to investment funds. In reality, it's unclear who truly owns it. For an ordinary person, it's hard to know where their place in all of this really is. But for us, it was different. If we imagine how it started, picture a single person with a soldering iron at a desk, putting something together. Something starts to work. It turns out, someone finds it useful. Then another person, then a third. Eventually, one person is no longer enough. They hire a second, a third, a fourth, and a fifth. But it all starts from zero. Everything you see today was built from the ground up. There was no takeover, no massive outside capital investment. Everything was created by us. 25 years ago, the company began by working on electronics for CNC machines. These were simple controllers for building milling plotters and modernizing older CNC machines that were mechanically sound but had outdated control systems. As time went on, we realized we wanted to manufacture complete machines based on our control systems. We started with milling plotters for the advertising industry, cutting graphic signs, banners, light boxes, and mostly plastic materials, composite boards, and wood-based materials. These were lightweight machines that performed excellently in this sector and quickly found a place in the hearts of our customers, especially in Poland. Many of those clients began using these machines for more demanding applications, and expectations grew that the machine would eventually work with aluminum and even steel. Over the years, these machines became heavier, more robust, and more rigid as we adapted to market needs. Devices were created that had not been offered anywhere in the world until now. We developed devices that can be described as either very heavy milling plotters or lightweight CNC milling machines. Until then, only very light milling plotters were produced, followed by a long gap, and then only very heavy milling machines. There was a clear need for devices to fill this gap, and we did it. Did we create something groundbreaking? I don't see it that way. To us, it felt like doing what needed to be done at the right time. When we were developing our control system, fiber laser machines weren't on the market yet. Fiber laser devices appeared roughly 10 years after we designed the dynamic analysis of vectors control system. When they emerged, we realized we were the only company in the world with a control system perfectly suited to this new technology. Because the solutions used so far could either be fast or accurate. Traditional control systems are based on technology developed 50 years ago, at a time when processors were relatively slow. To create such a control system, many compromises had to be made. However, a compromise is still a compromise, meaning something had to be sacrificed. A machine could either be fast or precise, due to what is known as a lagging control system, where the working tool always lags behind the interpolator, the computer controlling the machine, by a distance proportional to the feed rate. This where mechanics couldn't keep up with computers. This was a period of great IT development. We started producing laser cutters and showcased them at the Euro Black Trade Fair in Germany. This is one of the largest exhibitions for cutting and sheet metal processing technologies. It turned out that we were producing the fastest laser cutters in the world. That was over 10 years ago, but even then, we demonstrated that many components could be cut several times faster than on other laser cutters offered by other manufacturers at the time. The differences weren't measured in percentages but in multiples, which is why customers showed great interest in our laser cutters. They saw that one of our machines could replace several others. We quickly became the leader in the laser industry in Poland. In front of us is a laser cutter in the testing phase. Some people are even intimidated by this gate. When the doors are closed under normal conditions, the machine moves at high speed. At the moment, the machine is undergoing testing, which allows us to film it with the safety shields open. We simply fulfilled our customers' wishes. How did we do it? We created a program that's very user-friendly. Operators were accustomed to working with software like Windows, Word, and Excel. They wanted a program that looked somewhat similar. At that time, software for large machines was much more complicated and resembled calculators rather than computers. The devices we manufacture are extremely durable. They are designed to work for 20 years, and all the components we use are of the highest quality to ensure safety throughout their entire lifespan. The devices we produce are still being serviced to this day, even those manufactured 25 years ago. This is undoubtedly a success because customers know they can rely on us. And these types of devices are often purchased by them again. One of our customers owns 36 of our large format processing centers, which is a record for us. Importantly, we're one of the few, if not the only companies, that still offer free remote diagnostics and support even after the warranty expires. On today's market, this is almost unheard of. This policy stems from our philosophy of running a service department not to profit from it, but to cover its operational costs. We do not make money from service. Our company profits from selling and delivering new laser cutters, new plotters, and new milling machines. In this room, we assemble laser heads. The process takes place in a laminar flow box, which ensures that no particles from outside, even pre-filtered air, enter the assembly zone. Inside, optical elements like lenses and collaborating components are assembled. All production and technology used in our devices have been developed in-house across 3 departments: electronics, software, and mechanics. These 3 areas form the pillars of mechatronics, the interdisciplinary field that underpins modern devices. because we produce key components like the control system, electronics, and software ourselves. We can easily adapt them to meet new and specific customer needs. In many cases, this ability has opened doors to major clients and industry leaders. We're now in a room where laser heads are tested. Here, our devices perform comprehensive tests on optical, geometric, and thermal properties. This includes testing geometry, power, and absorption. Our company has always focused heavily on research and development. Initially, engineers involved in production also handled R&D. However, we realized that dividing their focus limited the efficiency of both production and innovation. That's why we made the decision to separate our research and development department into an independent unit, which is now located in a dedicated building, Kimla Labs, where we are currently developing software, control systems, magnetic drives, and laser cutting heads. Most of the solutions we create are based on our observations, enabling us to tailor algorithms and methods to achieve the best possible outcomes. Our servo drives, for instance, provide flexibility, allowing one drive to support various types of motors, including rotary motors with incremental and absolute encoders, as well as linear motors with nanometer resolution. The research primarily focuses on discovering new technologies and ideas that can be developed and implemented in our machines to enhance their performance, improve their efficiency, productivity, and precision, as well as increase their overall economic value. At the same time, we conduct numerous studies, some of which end in success, while others require us to take a step back to make 2 steps forward. However, this investment is never wasted, as the experience gained through these studies directly contributes to the development of new technologies, innovative solutions, and even entirely new products for our company in the future. From the beginning, this has been my passion. It drove me to spend sleepless nights working on ideas and solutions without feeling tired. That was true 20 years ago, and it still is today. I love what I do and can't imagine doing anything else. Creating new solutions, improving existing technologies, and striving for excellence bring me immense satisfaction. I'm also passionate about horseback riding. I spend a lot of time in the saddle, sometimes riding daily for weeks at a time. There's nothing like galloping 15 kilometers through the woods, feeling the wind in your hair and tears in your eyes. It's pure joy. We've installed over 400 laser cutters in Poland and many more abroad. We are continuously increasing our production because, at the moment, producing 1 laser cutter per week is not enough to meet the market demand. And we're building a new factory designed to produce 1 laser cutter per day. Because if we can sell 1 laser cutter per week in Poland, where is the rest of the world?